Okay, let's picture this for a second. You're sitting down, maybe looking forward to some uh, comforting biryani, with all those spices.
Love biryani.
Or maybe it's kheer, that sweet rice pudding. Or just, simple dal and chawal. It's such a staple food for so many people, especially across Asia.
Absolutely. Billions rely on it every day.
Right. But what if? What if that very staple food could, I don't know, actually be causing harm down the line, like in the future?
Well, that's pretty much the core question a new study is raising. It's in the Lancet Planetary Health, and it's definitely making waves.
Okay, so what's the headline finding?
Basically, it's projecting that climate change could significantly increase the amount of arsenic in rice, and that, in turn, might lead to a noticeable rise in cancer risks by around 2050.
Wow, okay. Arsenic in rice due to climate change. That
Yeah.
sounds, a bit alarming.
It does, and that's why we wanted to really dig into it today.
Exactly. So for this deep dive, we're going to explore this link, how climate change fits in, what the potential health effects really are, and importantly, what, if anything, can be done about it.
And look, we get it. Hearing arsenic and rice together might make you a bit nervous, especially if you eat rice regularly.
Yeah, definitely.
Our goal here is just to unpack what this study found, lay out the information clearly, without, making it overly technical or scary, just the facts and what they might mean.
Okay, let's start with the basics then. Arsenic. It's not something farmers are adding, right? Where does it come from?
No, not at all. Arsenic is a natural element. It's just there in the Earth's crust, in the soil, in the water.
Okay, so it's naturally occurring. Why is rice particularly susceptible?
It really comes down to how rice is grown. Those flooded paddy fields.
Right.
That waterlogged environment creates specific chemical conditions, low oxygen. And those conditions make a certain type of arsenic, inorganic arsenic, which is the more harmful kind, much easier for the rice plant's roots to absorb.
Okay, so the way we grow it makes it better at soaking up the bad stuff,
Yeah.
essentially.
That's a good way to put it.
So this isn't like brand new information that rice can contain arsenic.
Correct. We've known for a while that rice can accumulate arsenic from the environment, especially if the soil or irrigation water is contaminated. The real news here, the focus of this study, is how climate change is set to make that existing problem potentially much worse.
Okay, that's the crucial link. How does climate change actually worsen this arsenic situation in rice?
So this study, it was led by researchers at Columbia University. Louis Zisco was the lead author. They spent about 10 years looking at this.
10 years? Wow.
Yeah, tracking 28 different rice strains. What they found is, twofold, really. First, rising temperatures, specifically if we hit 2 degrees Celsius or more above pre-industrial levels, actually change the soil chemistry.
How so?
It makes the arsenic that's already in the soil more bioavailable. Basically, it unlocks it, making it easier for the rice plant to suck up.
So heat makes the arsenic easier to absorb.
Okay.
What's the second part?
The second part is carbon dioxide, CO2. Higher levels of CO2 in the atmosphere actually make rice plants grow faster, more vigorously.
Which sounds good initially. More rice.
Exactly. But here's the catch. As the plant grows bigger and faster, it also takes up more water and nutrients from the soil. And along with that, it takes up more of this newly available arsenic.
Oh, I see. So warmer temps make arsenic available, and more CO2 makes the plant take up more of everything, including the arsenic.
Precisely. It's like the plant is being encouraged to drink more from a cup that now has more arsenic dissolved in it.
Kind of like sipping a toxic smoothie it doesn't know it's drinking.
That's a disturbingly accurate analogy, actually. And the study really focused on the potential impact in 7 key Asian countries: Bangladesh, China, India, Indonesia, Myanmar, the Philippines, and Vietnam. Places where rice isn't just food, it's central to life.
Right. Now let's talk health impacts. You said it's not immediate poisoning, which is reassuring, I guess. But
Yeah.
what are the long-term concerns?
Yeah, it's crucial to understand this is about chronic, low-level exposure over many, many years. It's not an acute thing. But that long-term exposure is linked to increased risks for several serious issues. We're talking lung cancer, bladder cancer, skin cancer.
Okay, those are significant.
Definitely. And beyond cancer, there are links to heart disease, type 2 diabetes, some neurodevelopmental problems in children, and potentially even issues with the immune system.
So it's a gradual buildup, like a long con being played on the body's systems.
That's one way to think about it, yeah. It's insidious because the effects accumulate slowly, often without obvious symptoms until much later.
You mentioned earlier why rice is more vulnerable, the flooded paddies. Can you elaborate a bit on that compared to other grains?
Sure. Those flooded conditions create what scientists call an anaerobic environment, basically, very low oxygen in the soil.
Okay.
And it turns out that specific low oxygen environment is like a five-star resort for the chemical form of arsenic that rice roots are particularly good at absorbing.
So wheat or corn grown in drier, more oxygen-rich soil don't have that same issue.
Generally, no. They don't face the same perfect storm conditions for arsenic uptake that rice does in traditional paddies. Of course, you also have to consider the cooking water.
Ah, right, if the water itself is contaminated.
Exactly. That can be another source of arsenic, independent of what the rice absorbed while growing.
Okay, so recapping that bit, warmer temps, more CO2, and the flooded paddy environment all kind of work together. A perfect storm, as you said.
Yes, the study really emphasizes that combination. The rising temperatures and higher CO2 act like a toxic tag team, amplifying the amount of arsenic that ends up in the rice grain itself.
And that leads to the projected increase in cancer risk, the 44% figure.
That's the projection under certain climate scenarios by 2050, yes. Up to a 44% spike in risk, with bladder and lung cancer showing particularly strong links in their models.
That is a really stark number. Can we talk about the scale? Like, what does that mean in terms of actual people affected, especially in Asia?
The figures for China, for instance, are pretty sobering. The study estimated, get this, potentially 13.4 million additional cancer cases linked specifically to this rice arsenic issue by 2050.
13 million. That's staggering. It's hard to even comprehend that number.
It really is. And while China's population is huge, the impact is projected to be significant in other major rice-consuming nations, too.
Like India, Bangladesh.
Exactly. India, Bangladesh, Vietnam, countries where people might eat rice 2-3 times a day, that per capita consumption is just so high.
Right, so even a small increase in arsenic per serving adds up significantly across the population over time.
Precisely. It really highlights the vulnerability when a single food source is so overwhelmingly dominant in the diet.
It really puts the cultural significance of rice in a difficult light, doesn't it?
Yeah.
Something so trusted, so fundamental.
It feels almost like a betrayal, in a way. Finding out your staple food might carry this hidden risk. And the way arsenic works, it actively disrupts cells.
How does it do that?
Well, it interferes with various cellular processes. It's classified as a Group 1 carcinogen by international agencies, meaning it's definitively known to cause cancer in humans.
Okay.
And as we mentioned, it's not just cancer. Heart disease, diabetes, pregnancy complications. There's also emerging research on its effects on brain development and the immune system. It's kind of the overachieving villain of the periodic table, unfortunately.
That's quite a description. Now, the study focused on Asia, but what about the rest of us? People eating risotto in Italy or paella in Spain or just, rice bowls here.
That's a really important point. While the highest risk is concentrated in those regions with extremely high daily rice intake, 400, maybe 600 grams per person per day.
Which is a lot of rice.
It's a huge amount, yeah, compared to maybe occasional consumption in Western diets. But the issue isn't strictly geographical. Anyone eating rice is potentially consuming some arsenic. The dose makes the poison, as they say, but the baseline levels could rise globally.
So the risk is lower elsewhere, but not zero, and could still increase.
Exactly. And some places have compounding factors. Bangladesh, for example, already struggles with naturally high arsenic levels in groundwater used for irrigation. So climate change could exacerbate an already serious problem there.
Okay, this is a lot to take in. It sounds quite bleak. Are there solutions? What can be done?
Yes, absolutely. It's not all doom and gloom. Researchers are actively working on several fronts. One major area is breeding new rice varieties.
How would that help?
The idea is to develop strains of rice that are just inherently less good at taking up arsenic from the soil, finding and promoting varieties that naturally keep arsenic out.
That makes sense, like selective breeding for low arsenic uptake.
Exactly. Another angle is changing farming practices.
Like not flooding the fields as much.
That's one possibility, yeah. Different irrigation techniques, maybe alternating wetting and drying rather than continuous flooding. Also, adding organic matter to the soil can sometimes help bind the arsenic, making it less available to the plants.
Okay, farming techniques. Anything else?
Public health approaches, simple things really, like educating people to thoroughly rinse rice before cooking it.
Does rinsing actually help?
It can, yeah. It washes off some of the surface arsenic. Also, Cooking rice in a lot more water, almost like pasta, and then draining the excess water can remove a significant amount of the inorganic arsenic.
Okay, so rinsing and using more cooking water are things individuals can do.
Definitely. Practical steps for the kitchen.
But these bigger solutions, new rice breeds, changing farming, they sound challenging.
They are. Developing and rolling out new rice varieties takes time, years, even decades. Persuading millions of farmers to change long-standing traditional practices is a huge undertaking.
Yeah, I can imagine.
And cleaning up widespread groundwater contamination. That's incredibly complex and expensive. Plus, and this is crucial, none of these solutions will be fully effective in the long run if we don't tackle the root cause.
Which is climate change itself.
Exactly. Limiting global warming, reducing CO2 emissions, that's fundamental. If temperatures and CO2 keep rising drastically, these other measures might just be putting a bandage on a worsening wound.
So this rice issue is really a symptom of the much bigger climate problem.
It's a very pertinent example of it. It shows how climate change isn't just about sea levels or polar bears. It directly impacts our food security, our health, in really unexpected ways. Rice is like the canary in the coal mine for our food systems here.
If it's happening to rice, could it happen to other crops like, I don't know, toxic tomatoes or poisonous potatoes?
Well, hopefully not that dramatic. But yes, the underlying point is valid. Changing climate conditions, temperature, water availability, soil chemistry can affect nutrient content, toxin levels, and overall yields in many different crops. We need to be watching this space closely.
It feels like a cycle, too. Climate change affects rice, leads to health problems,
Which strains healthcare systems, impacts economies.
and potentially hinders our ability to invest in climate solutions. It's all connected.
Deeply interconnected. And there's a huge injustice aspect too, right? The countries most dependent on rice and often most vulnerable to these impacts are generally the ones who've contributed least to the historical emissions causing the problem.
That's a really important point. So for listeners wanting to do something, what are the takeaways?
Well, on a personal level, the advice is rinse your rice well. Consider cooking it with extra water and draining. And maybe diversify your grains. Don't rely solely on rice if you have other options like quinoa, barley, oats, millet.
Okay, practical kitchen tips. What about the bigger picture?
Support efforts to tackle climate change, whether that's through policy advocacy, supporting organizations, or making changes in your own consumption patterns to reduce your carbon footprint. Pushing for cleaner water initiatives and sustainable agriculture also helps. It all contributes.
So wrapping this up, the main message isn't rice is bad.
Yeah, not at all.
Well-
Rice itself isn't the enemy here. It's a vital food source. The issue is how climate change is altering the environment in which it grows, leading to this increased arsenic risk.
And the potential consequences, especially by 2050 in places like Asia, are serious and need attention.
Absolutely. This study is a really stark reminder of how far-reaching the impacts of a warming planet can be, touching even the most basic parts of our lives, like our dinner plates.
But it's not hopeless. There are potential solutions, smarter farming, better rice varieties, individual actions.
And crucially, climate action. We have pathways, but we need the collective will to pursue them. The future isn't set in stone.
So maybe the next time you have rice, it's worth thinking about this connection, not just for your own health, but for global food security. It really makes you wonder, what other parts of our daily lives, things we take for granted, might be subtly changing due to climate shifts?
That's the question, isn't it? What else should we be looking out for, and what can we do now to build resilience? Definitely food for thought.